I am Gabriela Moreira, research engineer at Informal Systems, and I work with Quint specification. So this is the agenda for our things minutes of files. I will give you a brief introduction of things. Then I should use specification language. Now, Jesus, places. What's right? Samples, working on that, on exactly. Now, what we like is generate infinite sense. The results. Talk a bit about how things this way. Was it again? Short one. Into Quint. And then end up with Greenland's Translate. I have visions so you can follow on if you want. These matters for it can work. So here you find the material that I'll show you today and many other things. Let's start. So what is Quint? Quint is a modern executable specification language. It's executable because it's better with English and Markdown. So we specs are written in English, they have Markdown file. We can actually get the name resolution, so you won't have typos in your names. You can actually check times. You can execute it and see if that's what you expect. You don't mark abstract. Then the training levels. So we'll have to define this one out. Every single detail. Perhaps some words like how you sort this. You know, I sort this thing. Modern. Because there are many specification languages on it, right? But they're very messy. They have like this old GUI tool that we don't like. We test, we want that perfect using text, you already know. We don't choose the CI, and we don't choose our any perspective schemats. We are base maps, yes, both are. Other sides. A bit more formal methods to formal specification languages. If you haven't learned about it. We're at this point by using formal specifications is that S choose so first. That's all research. But if that's not what you're doing, very smart people, certainly you should get them to have it from it. We can use them to find out very rare bugs. They just not find influencing stretch of any sort of advantage. Well, there's a challenge. It's really hard to use this and keep on it in there. So you already think, I'll just use Rust. Right, the ARM subscripts and ground SMTs over 40. It's really hard to change because languages are making. They have one-dimensional loops, so in a 5 files. It's hard. Next slide. You need a different type of language. So you stay within the bounds, this underlying logic that SMTs over can handle and you get benefit of. Also, this helps us stay in a level that's more appropriate for our goal. Say, like I was saying before, perhaps we don't care about how this is sorted. But at least we don't have to care about that. We only have to care that we got sorted list. And we do what we want. So this I just wanted to focus more on the abstract part of it. Which might be the most fun. Now we're reaching. This is the thing. Let's okay, so we have this is all open source. In whether combining your machine, whether your machine or double friend, NPM, no tricks there. GitHub repository, have a brand new website. To put out next week. Not a very thin but so let's check it out with the thing up board. This is me. So I'm this space lead developer of Quint, and I've been working it for the last 2.5 years. I might be a bit too passionate about it, so careful, but you can follow me on socials. Yeah, so that's it. And okay, now that reaching now, that's it for me. Very good. And okay, now let's try to say like one simple example. So I have a Quint spec. Well, big.qnt is the file extension to Quint specs. The qualifications there, you knowledge, deposits, and how to retro. And then you want to check some garrison. The balance should never be negative. There's no such thing as having negative. I don't have like minus 10 actually. Then you send this back to another checker or a simulator. So another checker is the fancy part, and simulator is kind of like easier to start with, and then we go to the another checker, which is like very, very good. Anyway, you send to one of them, and they'll get to us for response. First, well, good. Yeah, now this is kind of negative. You succeeded. You've made a good model, good for all resolve the violation file. And in this case, the good thing about it is that it gives you a specific trace where the violation rule. Okay, so since 0 this happens, state 1 this happens, state 2 this happens, etc. So even working with me, don't worry, this will be zoomed in. But this is the whole of the squid spec for the case map. All that you need to run it is right here. And then we get that file. So this is the CLI page from file. You give it the infrared, which here are called negatives. You get this result. So here, seeing 0, Alice had 0, has 0 tokens, and then somebody, she has minus 63. That's a problem because we're trying to check the balance of our negative, never negative. So if your Quint says code violation, violation, then it gives you exact how we can achieve this issue and you reproduce this. Well, and this is the first one from the workshop. Really well, try a small one, but there are negative balances in it. First milestone. Let's try to understand the spec. Let's look into the details. First concept is Quint models. They are just state machines. I put up state machines in a position systems. So let's see how we define. So first, we need to define how we say initialize. What is the initial state or what are we? So say here we will say all users start with 0 tokens in their box. That's how we will start. The only other thing we have to do is define a set, which is a way to define all the possible organizations in a very abstract. So here, for example, we can say let each end user, so any of the users I have, can either product or withdraw any of them. Bunch of choices here, but this is fine. This is our different positions. This is what can happen to move from one state to another. I think like the most other new concepts. The prime operator, which is like this little thing. It represents the next state, so I can write things like this. Total supply in the next state is equal to total supply in this state. This is how we frame positions. Okay, mark with basics. We have layers. First, we have a functional layer. If you have to use any functional language, or even this language that programming language that has functions, it should be super perfect there to use. This is where we define business logic. And we have this classification to help us understand how much we're reading from the same. Because things, global variables is kind of like we want to be very aware of when we are reading from the same. So we have these keywords here. You can either have pure depth, pure vol, or vol. Pure means you cannot read from the state. It's like for pure functions. There's no side effects and you don't read from the state. Depth is a difference between depth and vol. That depth means they have parameters, while vol is the same parameters. Depth is a function, vol is a value. So this is similar. Actions that you might have not seen before. And this is how we define state machine. If you want to understand really what actions mean, then this part is a big part. How we actually need to understand this. They are just Boolean expressions. They are true for a step from a state S to a state T. So we take a step, in combination of like a state now and the next state, and then you evaluate this Boolean expression over it. And this is how we define actions. So they're Boolean expressions. And then all actions is often when we start having no terms. Pick any amount, pick any user, pick any of these options. And then last thing, we have properties and routes, which are kind of what we want to step, what we want to find out of our model. We just define it using actions and functions. So in because this is an important day. Let's look into it. We have some special operators. First of all, It just means that all of the actions you're putting into the recurring braces here, separated by commas, all of them need to hold. So in this case, both this is hold. Both x has to be equal to 1 in the next state, and y has to be equal to. For any of the actions need to hold. So either just x will be equal to 1 or x will be equal to. And like the singular logic will be each one of these non-determinism. Non-determinism, this time non-deterministic values. This is for actions. This is for values. So I'm sorry, but I'm declaring an that value phi. That will be one of the best this range from 1 to 10. You can assign this value phi to a singular state. Again, singular logic will be one of the values from the set from the deterministic linear functions. Okay, this was some examples. Let's take in practice now then. To the first extension. It's when you're speaking. Okay, so we have zoom here on this. Here first I have this bar. Here, this is declaring like an element of the state. So I'm saying right now, this is here. The state is the state bar. It's part of the circles that represent the state. Here I have pure value. So this doesn't depend on the state at all. It's just you can see as a constant. This is how we are going to find state. Here you can see the prime operator, which I told you, refers to the next state. So I'm saying that balances in the next state is which balances in the state where like the current balance of account is updated as entering the current to out, which is what is being deposited. And these two, like both deposited from here, are actions. You can see right here, keep one action. So these two can both read and modify the state, which is what they are doing. They are reading the balance of the person who is doing the action. If you try to write edging or reducing the amount of resistance. For the second part, we're going to look, so we have the unit definition. I told you like all letters start with 0. Then we have the step, and then you can see some other terminisms. So here I'm teaching a value for the amount from a set of interests. And I'm thinking a value for amounts from this right here. And I'm trying to arrange it just from a step. So here we see a combination of one and one off. And any value can be linked. And here I'm using another type of non-determinism, a problem determinism, where I'm thinking like I could to deposit or any of these actions in for each set. Finally, I have invariance here. It's actually a single value, but we can see it's a property. So it's saying all addresses, the balance of the address has to be greater or equal to 0. Next. Okay, so this property has to hold, it has to be true in all original states. And I haven't shown you all, which I insist that I haven't shown you the fact. Actually, we have to fix the bug, right? Because we found the bug there where else had minus 16. So okay, that's bad. So let's fix the bug using all. So here I changed it in control action. I added this recognition here. And I'm wrapping this in an all statement because I know I want this to be true. I want all the precondition, which is direct balances for, say, Alice or for the person here that is trying to be greater or able to not. So this is a precondition, and this is a transition. Balances in the next state equals blah. So now I have this all because both of these need to be true for this action to be true. Yeah. All of these need to show. That's 15 minutes friction.
Yeah, right. But it's you're 5 minutes.
Yeah, it's 15 minutes friction. And I mean like
15 minutes.
50. 50.
Oh, 50.
Yeah, just she doesn't have a lot more stuff. So, okay. So you're going to be the first example. Pokemon battle. So for a Pokemon battle, in Pokemon can they want to do anything their attack. So actually Pokemon's a big game, so we're going to start with that. So first we're going to go 1v1 battle, worry about teams and change the players. And you're going to have to want some things. So first, example, which is an effect that is always elemental factor, always gives damage. The elemental attack that gives base damage to money. Switch is mental plus. So from one of other time, gives more damage on the piece of fight. This works that the fighter. And so on. Don't consider anyone young battle and it's too possible attacks first. You want to show or don't always be true letters. So I can use a fair or different Pokemon just so you can show the property. But we are going to show this word of obviously true in there given this slope. So actually we're going to try two versions of this thing. First we're going to know well the rules of the game and then we are enter strategy. So if you think of this like the rules of your world, your system, and the strategy can be like let's so for rules, we have to know that in each state, we can pick the Pokemon randomly from set Pokemon we have for each speed that they use with it. And there's the speed factor, so Pokemon with higher speed and way first. And then each turn, Pokemon will make an every state action from its attacks. Rules. You don't know how they are going to play, you don't know what they want to do. So they can know them basically, either Pebble or Arizona. And then let's my block thing. He said, we're going to change this part. Instead of the player choosing on if they're mystically what they're going to go, we're going to make the players really smart and they're mystically abstract. And in this case, you can show. Oh, sorry, it's just. So you got the stress. So I'm going to find this information. So in the rules, there is a possibility that Charmander is swirl. Okay, you got a swirl times itself. Sometimes the player because it's so much tackled. While in the strategy, we can prove that a swirl always be Charmander. Please attention. So, live demo. Let's see if I can do this. So this is my Pokemon set. See, it's okay. What I have here, it has some types. So if you for name parts, we don't have standard library. Yes, so it's weird, but it's funny. We have types here. Some types, so water for grass. We have them modifier that's can be super effective, not very effective, normal or normal. A set of Pokemon here. I'm only going to sport of both Bulbasaur and Charmander here. And I have a state. So a state is only a map of Pokemon. And then this variable that controls the information of turns. The way each player has things like one time and that's accidents. It's the other players. I have some auxiliary definitions here. The important part is here. So this all things the damage modifier. Sure, that's just like so say like water affecting water, it's not very effective, but water affecting fire. It's actually super effective. But this is where I find it stuff. And here, oops, I have my sweatshirts. Sorry, my skins. I have tackle, which always give standard. And I have elemental attack, which will use the damage modifier function to see if it's super effective, it will give double damage. If it's very effective, have damage, and normal to base damage. And then I update my Pokemon's variable in the next state, Pokemon's variable. For attacking, I have here some conditions, regulations, I cannot attack myself, and I have to be, both that has to be alive in order for one to attack the other. So HP's health points, and here's the part of like, it was, and so either the player can either damage, so attack or attack. Let's say this is a start contract, the user can hold either entry point, we cannot control what the user decides to do. Yes, and then I just have the gates, which will go back, we're not going to miss a peak of focus, we're going to be battling, and sort out by speeds to see what starts. And my staff, if there's Pokemon are alive, they will less. And I will do a prediction of the team, else, just stays the same forever. And here I have a property. My property is called Charmander cannot eat squirrel. And I'm saying that if there is the most of this can be like a battle between a Bulbasaur and Charmander. So I can look at it like that. Between Charmander and Bulbasaur. So I'm actually using it in communication. So I'm only going to care about this property when there's open offside fire and there's open offside water. So if that's the case, there is a Charmander definitely Squirtle. I want to make sure that Squirtle survives. So Squirtle has more than 0 HP. And this has to be true for all states. Okay, so this doesn't matter, like, I'm checking this by the battle line. So it's always has to be true. Like, Squirtle has to be alive forever. Typing goes transfer, you know, and I hope it's flat, so I can see it. We will see Pokemon. And I took stage run. My stat Pokemon, and I call this variant Charmander Talents. And I'll run things. He's on violation law. What happened? Squirtle died. So Charmander actually beat Squirtle in this case. Then we can walk and actually like do this flag here and just to be more about what happened. So I can see like there was a bunch of tackles here, tackles. And I can say, look, this I would understand that actually search for there's been and not to be my something, which is effectively beyond. So now let's go to the second word, which is strategy, brain. And here is or instead of doing this manager, mistake they have actually enemy statement and say you can right. Sorry, there's this like things weird. The enemy modifier between the attacker and the receiver, it's super effective. Then I want to do a laser. Now, oops. Now I have my strategy here. And I need parentheses. Okay, I need to use so guys. I don't have that for me notice. I can use. And now I can run it again with strategy. And in this case, we should not get any violations because now we're using strategy and it's part of how we solve each other. The thing is, this implement for Quint is using just a random simulation. So we can see like this was random values and trying to break the property. And like trying here for it's trying here for 10,000 steps. It doesn't say. It says that your being is max and both. So basically this doesn't give me form of verification. This just runs some tests. If I look to the form of verification, I have to do some really hard and chain and run to verify. And now this will be actually the chapter which uses the physical VPC tree. And it will do a bunch of reloading and verify the property from the error. So this actually proves to me that up to 10 steps on levels of functional steps, there is no way in that up to 10 steps. Square obviously sure matter if using the elements of sex or using the strategies. Proof that both most strategies happens. This second milestone. Time. And by the way, hormone status, it's pretty much like a smartphone track. So let's just look at it. So this is stateful. So that's hormonal health points. And contract states would have 1 points. Yeah. We have partial order in the sense, like in this case, the ordering of the metals depends on the speed. There are which Pokemon that are eaten. Here with 2 Pokemon is kind of easy, okay? My contracts are independent on stuff like AD, which is super complicated. We have monetarism. Here the players choose their attack, you close mark the index user can follow any entry points. And we have warranties that we want to show. We want to inject this instruction strategy for the Pokemon, and for much contracts we want to maybe check. So yeah, these Charmander will be sort of afraid. Here are over the Pokemons. Now let's talk about tests. So, let's picture the scenario. They have your implementation, you roll some quick models for it, and then you found bugs on that. And then you change your model, fix those bugs, and now your model is permanent. Perhaps on this, there might be like 2 moments where you want to judge base with your implementation because you care about it anymore. You care about implementation. So between 3 and 4, so you found your bugs in your model. Because maybe implementation you have to make a mistake about modeling. Okay, so you want to judge base with implementation here. Mainly after 5. Okay, your model is perfect, but what about implementation? Why is your model is not the same? Why did you make a mistake? So we want to make sure your implementation is also perfect. And the solution for that is model-based testing. Testing that's based on your model. Also known as MT. What the timeline for these specs? At least for how we use big specs and promises and for audits and stuff. Is we first figure out like write the model. And that's based on like an idea we have or the existing code, the existing implementation. Then we find friend properties about model, potential friend bugs, and we iterate the model, fix the model, consider it's perfect. And then we write an adapter. The adapter means we trace this. So nothing that I'll show you want to turn it on with the logs of the data and what have you. In JSON. And then write an adapter that reads the JSON, and for each step produces that step on the implementation. Run those tests. So these are any tests we use the adapter and run the test so we can see if the model matches the implementation because all the traces that are possible in the model have to also be possible in the implementation. And this you can run as many tests as well. You just have to test traces and then have more tests. Have infinite tests. So I'll show you that for the bank software. We have a model for the bank. The model is perfect. The model like we verified a bunch of properties. Imagine that we're really trusting this model. So we write an adapter, which is under the folder chest. And we're doing this in Rust to give you the scene language. Although Rust is a bit better. Write an adapter. Suppose we have an implementation that wants that. So from the model, you take the traces with an adapter and that has to read the function. The section. So this is how we're pretty. And I made just a little more complicated than I showed you before. This made it more interesting. So on top of transfer, and this has some like the possibility of returning errors. On top of not only just transitioning the states, we have errors as well. To check stuff. Then I also had this like 2 functions, buy investment and sell investment. So can I buy a share, we can pay for them and we can sell them. Just made it more interesting. And then I have some helpers here that help me call the pure function and assign results. And I have some actions here where I make the non-heuristic things. Or just feel it's fuzzy. Are you familiar with this? Setting your parameter ranges. I have a action for each of my pure definitions. So we keep things tidy. And I have my initial states, the 0, and I don't have any investments, and I have the investment ID. And I also have a variable strength and a standard. The same thing can. And then I have a similar implementation here in Rust. Well, the same stuff. Okay. Slider is a bug. It's not easy to see. So, like, if you stare at this code for perhaps, I don't know, 10 minutes, half an hour, probably you can find the bug. Kind of simplifies it here. Be smart, maybe. So, but this is a very small example. Staring at code, view connection code is my partner. And here I have my test. Okay, so I have one model. I have implementation. This is the test. So it has a bunch of configurations here for some variables, but it's a very important thing. Important part is we compare the error here. So there is an error trees we also expect that there is an Android application. And on their app, there's an Android application, then there should be also an Android. No, so we want to see if the data breaks. And then I'm doing that here for modeling tests. I am reading a trace for that test. And it's the surface when the boss actually the trace our foundation will vary range the actions. Open file just to show what's on inside. So I make exactly for trace. And now you see it there, and I ask it to generate 10,000 traces here. Barley number that I want. And then I put on purposes. This part takes up 1 minute, so I want to do it now. And when we run purposes. So first thing that I broke storage. So I'm here, I have my traces. I have 10,000 traces here that have been generated for me. And I will run purposes. And let's see if I find the bug there. Oh, it did. That's not my damn works. Okay, so you said was supposed to fail with never saying that there's no investment. He got actually succeeded. So I must not be 2%. If I go for the goal, this is the goal. There is this check here. No investment in this ID. Oh, I did checking for it. There is like the deceit here. And if I look at this for, I don't know, like 5 minutes, maybe less, I realize when I'm selling investment, I'm actually not removing it from the set of investments. So it continues there. And if I try to sell it again, it will be there. And that's wrong. That's not supposed to happen. You got 7 investments twice. So I realize I have to remove this investment from my set of investments, which is under bank stage estimates. And I'll remove investment ID. And actually, this has to be this. Okay. And now, it's the same. I haven't changed the model, but I just have to run this again. And now, we just take my limitation matches the model. And this will take a bit more time because we're going over 10,000 traces here. Let's see if they match. What they should match. If this is very useful for finding bugs in our spec, in your implementation, and also like seeing if you made any mistakes or right now, because if your model is wrong, then the property to prove our workspace. Let's see, it should take less than a minute. So, and I have, I don't know, I lost track of time. 10 audience. So match this line. See, this is taking so long, and then we'll go back in yes. Oh, so now we see test result. Okay. So now we fix it. And this is how we found and reproduce in actual code using Quint. So we could find actually several ones in the bank. I've said just show one, but like it because I fixed them before. But like in each statement, they're removing the bank, the Quint are able to identify. We use model-based nesting purpose. So this is the third milestone that comes right here. And now I want to show Cosmos an example. Unfortunately, I won't be able to demo this because it's a bit too long, but I have everything on the internet for you guys, so you can check it out if you're interested. This is extra help for any of your Cosmos developers. Here's the Cosmos. We have this tool called Cosmos Explained. It's also that's a triple beginning, where you can generate cluster models. So you have to write so many credit, save your time. So student will just read your contracts and generate a bunch of big boilerplate, which is not a lot. But if your contract is win, it's a lot of time. And actually, you can also have a big model with testing out the work because this tool, since it knows how the spec is structured, it can write the adapter for you. So if you just write a tool and then you go to the model and you fill the parts that are missing and some mistakes there, you can access test review and on verification you can write your margins. With a shortcut for Cosmos and devs. So instead of doing a demo, I'm doing one pointer, so I have this name here. It is also on the cosmos to reach repository. So if you found that you're code already, we have whole demo for how, like step by step, how to find bugs using this tool for a captured file that's test that was done by security. So we can show you how to use Quint and this tool to identify the bug and capture flag on the system. So this is a small database test for bug models. And then using the automation, and if you refer to the link, you can find bugs which much less work if you're using Cosmos. And this is the CTF01, so capture flag number 1, with Cosmos to like the tool. And this is my last section, ways to use Quint. Stop staring at goal. Like Quint, staring at goal hard. Not staring at goal by your own margin. Margin is difficult. And that's if some documentation is a bunch of code, you have to read code and understand what's going on. But Quint specs, they're attractive. Run them on the REPL. We can ask Quint like, hey, is there a state where Alice has 33 tokens? Is that supposed to happen? And then we can understand how you get to a state that you're trying to get. To learn, to onboard, to I have used Quint myself, like the roles, while I was trying to understand. SS20 was really helpful for me to understand how traces get changed with transfers. So I really recommend that for onboarding. It can become actually your pen and paper when you get really good at it. Don't stare for a while on the team. I recommend it. Something is really hard to find once just by staring. So if you wonder if something like shading with the function or with directions between function and function wise, the left part in Quint and see what happens, and you know for sure. Don't start code choice test and just come into how Quint generates test. If you have Quint with this, like when you're writing test, usually we're trying to like, well, come up with all possible scenarios. So what if the balance is negative, or what if the amount of investment, or what if this happens, or what if the investment was leading? If the investment is that you have to think about all of that in your head and write a test. Quint does that for you. And you can have some assessment logs. Don't stare at diagrams to consider all diagrams. Diagrams are good. I'm not sufficient about diagrams. But you can also execute the following things. It's very useful to see like what can happen and take this test yourself. Okay, this one is it. Don't stare at mistakes in a checked specs. So how many of you have for reading like a specification marked on it, so oh by the way, it's a typo here. You go there, open up the arch, fix the typo, and it's like, oh, it's me. Or like this is supposed to have the same type, but it's actually different. What happened? Oh, someone forgot to update it. Oh damn, now I have to fix it. Oh, it's not good, guys. It's better. Whoops. And finally, right please. And they give you many valuable things. It's not like these are all not like featured web routines when they're like trying to make it more like making so far stuff. It just does it as a form of simplification does for you. So I think it's just language. And it's great. It's also good for Marty for fighting us for generating tasks. It's for understanding your protocol, understanding your system. And yeah, stay connected. If you want to work enough. We have some job content if you want to have an audit with us or anything, like a complicated protocol, in which make sure this works for all systems. Also follow me on Twitter and check out the new website because it's really a lot of fun. So some questions in me. That's fine. You first.
The end of that area needs some verify. Person said, well, I would run. Is that possible?
That's like she actually maybe doesn't have to link understand this so much big thing. But like verify, I can give you like one time for example, for spreadsheet and you do slot. Or I can go through all scenarios. So there's not really a reason to do verify because verify is just like a complete exploration. You should just ask the simulator to go give me like 100,000 states. Exploring until it finds 1,000 states. So there's no need to like verify is just like An additional thing that makes there are some other stuff that can use like the something teeny about how SMT sovereign rate. So there are supposed to be different people. On that way, to get what's the rest of it. That's not much to do with the chat, so there is a and I think there's a big reason why we should do this.
Excellent.
We're we're
These version finds scenario the simulated podcast.
yes.
What she created a run that for 50 in the same sheet.
Yeah, I wonder if another doesn't on the situation, and it's not screen specific, but here. So the situations you have here said quick, but send the other parts. There's no sequence of first screen and there's some overlap. It's possible that this is the same bond, same coordinates, the same blind spot. Both in the span. To me, combination. Maybe one hand, maybe this.
The thing is, if you have properties for, then you should not have bugs in it. Okay? The thing that makes your model ring checks is that her calculation problem. So you're really confident that her model is correct. Okay, and that's why you're using it to test her.
So that means that people writing the model full and extreme confidence in the models.
Yes.
So if you run the same box, the properties of the model or in the models, it's not well and in the hosts, right?
Yes. So like if your properties are out be written, oh yeah, that is also. I think it's one that's likely. Yeah. Just like if you're just using tests, that's also like a very different language. So that just if you just think things hard. But yeah, I acknowledge that writing properties is hard. So it is a problem. Makes sense.
If the other is not way, that means there should be no overlap and you want to be in the teams. Or it should be like if person was fast, before we started.
Definitely, that's ideal. Like first writer's guide. It's left part, which fairly close, which is the he claims that you never do things without those facts. It's crazy because a bunch of resources building something like that's the same form of verification. You should do it first, you should model first, think about it. So like in the cases where you can do that, it's not the reality of yourself. Just the limitations of it there.